Assalamualaikum and a very good day to all students that taking this course, which is process instrumentation. Today we will continue with chapter 4, which is part 2 of the chapter 4 under the topic of sensor and transducer. This topic is quite vast, that's why I already separate it into two parts, and then the lecture is being subdivided into mini series of lecture to give you better understanding what is about this topic, which is sensor and transducer. Like I mentioned previously, this topic is very vast, that's why it's being divided into different part and also subdivided into different mini lecture for you to to go through the video so that you can have a better understanding regarding these topics, which is sensor and transducer. So for today, we'll begin our lecture with part 2 of the sensor and transducer, in which for this topic, part 2, you will learn at the end of the topic is the selection of transducer, the type of sensor, the application of pneumatic and electrical signal in process industry, and the comparison between each sensor. Okay, you might need to do that each sensor they have their own characteristic, and then they can be applied to many applications. So there is a comparison between advantages and disadvantages between each sensor, and from these advantages and disadvantages, you can make judgment which type of sensor is best for you to be used in certain application. Okay, type of sensor. The first type of sensor for this topic is the flow sensor. Okay, flow measurement is the quantification of bulk fluid movement. Okay, flow rate and the quantity is one of the important process variable requiring frequent measurement. So since this is flow measurement, you need to frequently measure it because it's continuous flowing. Okay, flow rate measurement play an important role in plant material balancing, quality control, and the operation of any continuous process. So for any continuous process, flow measurement is very vital. Okay, in engineering context, the volumetric flow rate is usually given by symbol Q. Okay, and the mass flow rate is a symbol is being sublocked. Okay, flow measurement find application in transportation of fluid and slurries, gas and water supply system, irrigation system, and industrial process control. That's why in fluid measurement, the application is found in the fluid and slurries because the fluid and slurries is being transferred from one point to one point. So the flow need to be measured. Okay, and also the gas and water supply system, meaning that the gas and water is being supplied from one point to another point. So the flow of the gas and water supply need to be continuously monitored. Okay, many accurate and double method are available for the flow measurement. Basic term in flow measurement. The first basic term that we encounter in flow measurement is velocity. Velocity can be defined as a measure of speed and direction of an object when related to fluid and its rate of flow fluid particle in pipe. Okay. Whereas the laminar flow can be defined as a flow of liquid occur when its average velocity comparatively low and the fluid particles tend to move smoothly in layer. So the laminar flow represents the condition on how the situation of the particles in which it tend to flow smoothly in layer, okay, in the flow. Whereas the turbulent flow is referring to flow occur when the flow velocity is high and the particle no longer flow smoothly in layer and turbulent or a rolling effects occur. So this is known as turbulent flow. The name itself suggests the condition in the flow is quite rigorous in which there is turbulence in it. That's why the particle no longer flow smoothly in layer. Okay. On the right hand side of this slide, you can see that the condition of the of every basic term and the iteration on how it really look like in the pipe. Okay, for the velocity you can see the measurement of speed and direction. You can see the speed and the direction of the flow, whereas it's going to the right hand side. Okay, for the laminar flow, you can see that the process is quite the particle is moving very smoothly in a layer, whereas the laminar flow, you can see that the direction of particle is quite in the undirectional, in which they are moving to a lot of side, because of turbulence in the flow. Another term that more commonly you will encounter when discussing about velocity about flow is that the viscosity itself. Okay, a property of gas of liquid is a measure of its resistance to motion or flow. So viscosity is its resistance to motion or flow. Viscosity dynamic can be measured in poise or centipoise, whereas kinematic viscosity without force is measured in stoke or centistoke. Dynamic or absolute viscosity is used in the Reynolds and flow equation. In the table below, you can look at the list of conversion. Okay, typically the viscosity of liquid decrease as the temperature increase. Okay, as viscous liquid such as syrup has a much higher viscosity than water, and water has a higher viscosity than air, syrup, because of its high viscosity, flow very slowly, and it's very hard to move an object through it. So just imagine a syrup in the pipe, and you tend to move an object through the syrup in the pipe. Due to its viscosity, you will find a resistance to the motion of flow of the object from this point to this point because of the viscosity of the syrup itself. Okay. This table show you the conversion factor for dynamic and kinematic viscosity. For the dynamic viscosity and kinematic viscosity, it has its own conversion factor. Reynolds number. Reynolds number can be defined as a derived relationship combining the density, which is ketumpatan, and viscosity, kelikatan, of a liquid with its velocity of a flow and the cross-sectional dimension of the flow, and take the form in the formula below, where V equal to average fluid viscosity, D is the diameter of the pipe itself, rho is the density of the liquid, and rho is the absolute viscosity. Flow pattern. Flow pattern can be considered to be laminar, turbulent, or combination of both. So you need to remember the pattern of the flow. It can be laminar. The particles smoothly transfer in the in layer, or it can be turbulent, or it can be combination of both. R equal or less than 2000 is laminar, makeshift resistivity, whereas 2000, in between 2000 and 5000, the R can be laminar, turbulent, or mixture depending on other factor. Whereas if the R is beyond the 5000, it will always be considered as a turbulent flow patterns. The flow rate is actually referring to the volume of fluid passing at a given point in a given amount of time, and is typically measured in a gallons per minute (GPM) or cubic per minute (CFM), and etc. Okay. Another basic term that we encounter in flow is the total flow. Total flow can be defined as the volume of liquid flowing over a period of time, and is measured in gallon, cubic feet, liter, and etc. This table shows you the flow rate conversion factor. How you want to convert from one unit to another unit. This will give you a good view of how the conversion can be done. Flow measurement instrument. The flow rate. Differential pressure measurement can be made for flow rate determination when a fluid flows through a restriction. Okay. The restriction produces an increase in pressure, which can be directly to directed to flow rate. So once a flow try in its flow is the flow is transferring from one point to another point, there will be restriction, and this restriction will continuously producing an increment in pressure. And then figures this figure okay, on the right hand side, on the right side of the slide, you can see the example of commonly used restriction. The first one is the orifice plate, the A. You can see the flow, and then you can see the orifice plate is being inserted. So it will produce a restriction to the flow. Whereas the diagram B show you the venturi tube, how the tube light and how it restriction is being inserted uh, into the into the flow. Okay, you can see that it look like a camel bump for the venturi tube. Whereas in diagram C, you can see the type of restriction, which is known as flow nozzle. So at the end, there is a nozzle in which the space of the flow, the space of the pipe is being reduced by inserting the flow nozzle to put a restriction to the flow. And then another type of restriction commonly used in flow is the del tube. You can see how the del tube is being inserted into the pipe to put a restriction into the flow. Okay. Orifice plate. Orifice plate is normally a simple metal diaphragm with a constricting hole. The diaphragm is normally clamped between pipe flank to give easy access. So normally the orifice plate is inserted between pipe flank. Okay, the differential pressure port can be located in the flank on either side of the orifice, as shown in the figure A. You can see here in figure A, the pressure port can be located, okay, in either side of the orifice plate, okay, or alternatively at specific location in the pipe on either side of the flank determined by the flow pattern named vena contracta. A differential pressure gauge is used to measure different pressure between two ports. So the different pressure gauge is used to measure different pressure at different ports. Okay, the differential pressure gauge can be calibrated in flow rate. The lagging edge at the hole in diaphragm is B-level to minimize turbulence. So in order to minimize turbulence in the flow, the lagging edge on the hole in the diaphragm is need to be bevel. Okay, in fluid the hole is normally centered in diagram C. You can see in the figure A. Okay, however, if the fluid contain particulate, so however in, let's say you just imagine in the fluid there is a particulate in it. Okay, the hole can be placed at the bottom of the pipe to prevent a build up of particulate. Okay, that's why you need to put, because when a fluid contain particulate, the particulate density tend to be higher than the fluid itself. So it tend to form sediment. Okay, sediment after a period of time, the particulate that are moving, it will in the fluid, it will eventually form a sediment. So the sediment will continuously build up again, and then this will prevent like what you say, causing the condition of blocking ataupun dalam pipe itu berlaku tersumbat. That's why the hole need to be placed at the bottom of the pipe to prevent build up of this particulate. Okay, the hole can also be in the form of semicircle having the same diameter as the pipe and located at the bottom of the pipe as figure C. The venturi tube. Okay, the venturi tube shown in the figure, you can see previously this one, the venturi tube here. the figure here, the venturi tube here, you can see the venturi tube here. Okay, so it's explained here. Okay, so the venturi shown in the previous figure use the same differential pressure principle as the orifice plate. So actually, it's using the same fundamental principle as the orifice plate. This one, I'm mentioning about this one, the orifice plate. Okay, so the venturi tube normally uses a specific reduction in tube size and is not in larger diameter pipe where it's become heavy and excessively long. The advantage of the venturi tube are its ability to handle amount of suspended solid, it creates less turbulence and hence less insertion loss than the orifice particle. You can see here, this is the advantages of the venturi tubes. Okay, the differential pressure taps in the venturi tube are located at the minimum and maximum pipe diameter. The venturi tube its advantage is that it has a good accuracy, but the cost is slightly higher compared to different restriction that you normally encounter in the pipe. For the flow nozzle, this previous one, for the flow nozzle here, I am talking about this, the flow nozzle, eh, the flow nozzle is a good compromise on the cost and accuracy. So it has the best balance. The cost is quite minimum, but yet it still have the accuracy between the orifice plate and the venturi tube for clean liquid. So compared to venturi tube, this one compared to venturi tube, okay, compared to venturi tube and orifice plate, the flow nozzle is actually a good compromise between them. It can give you a good accuracy, but at the same time the cost is quite the minimum. Okay, it is not normally used with suspended particle. Its main use is the measurement of steam flow. However, you must remember for the flow nozzle, it's not it cannot be used with particulate. So it's normally mainly used or majorly used in the measurement of steam flow. For dual tube, this one, for this one, for dual tube, talking about this, okay, the dual tube has the lowest insertion loss, but is not suitable for use with slurry. So any flow with slurry is not, you cannot use the dual tube. Okay. Typical ratio, beta ratio, which is the diameter of the orifice opening divided by the diameter of the pipe for the size of the constriction to pipe size in flow measurement are normally between 0.2 and 0.6. The ratio are chosen to give high enough pressure drop for accurate flow, but are not high enough to give turbulence. A compromise is made between high beta ratio D over D, which give low differential pressure, and low ratio, which give high differential pressure but can create high losses. To summarize, the orifice is the simplest, cheapest, easiest to replace, least accurate but even least accurate and more subjected to damage and erosion and has the higher loss. Okay. Whereas the venturi tube is more difficult to replace, most expensive, but yet it is most accurate between the type of tube, has high tolerance to damage and erosion, and is the lowest losses of the three tube. Whereas the flow nozzle is intermediate. I mean, it's a compromise between the two and offer a good compromise between the venturi tube and also the orifice. Whereas the dull tube has the advantage of having the lowest insertion loss but cannot be used with flow with slurry. Elbow. The elbow can be used as a differential flow meter. Figure here show the cross-sectional of an elbow. When a liquid is flowing, there is a differential pressure between the side and outside elbow due to the change direction in the fluid. Okay, so the pressure direction is proportional to the flow rate of the fluid. The elbow meter is good for handling particulate in solution with good wear and erosion resistant characteristic. But however, the sensitivity of this type of measurement is quite low. Pilot static tube. The pilot static tube are shown in this figure on your right side of the slide. Okay, it's actually an alternative method of measuring the flow rate, but has some disadvantages in measuring the flow itself. In that, it really measure the fluid velocity at the nozzle. Because the velocity varies across the cross-section of the pipe, the pilot static tube should be moved across the pipe to establish an average velocity, or the tube should be calibrated for one area. Other disadvantages are that the tube can become clogged. So the tube can become clogged because of what? With particulate. Because when the flow start flowing, to this pilot static type, when the flow have a slurry, the slurry will start to build up here. And with time, the slurry will continuously build up and eventually it will block this area. So at last, this will cause the pipe to be blocked by the slurry. Okay, that's why slide may not be enough to give the required accuracy. Okay, the differential pressure in any of the above device can be measured using the pressure measuring sensor discussed. Rotameter. Variable area meter such as the rotameter are shown in figure on the left side of the slide. So this is a rotameter. The rotameter is oftenly used as a direct visual indicator for flow rate measurement. So it gives you a visual indicator here of direct measurement of the flow rate itself. Okay, the rotameter is a vertical tapered tube. Okay, with a T or similar shape width. Okay. The tube is graduated in the flow rate for the characteristic of a gas liquid flowing up the tube. So then you can see here the gas or liquid are flowing up the tube. Okay. The velocity of the fluid or gas flowing decreases as it goes higher up the tube due to increase in the bore of the tube. You can see here when the velocity of gas flowing decreases, it will continuously go high up the tube. Okay, and then however the velocity of the fluid or gas flowing decreases because of what? Because the increase in the bore of the tube. Okay, hence the buoyancy on the weight reduces the higher up the once it go up. Okay, an equilibrium point is eventually reached where the force on the weight due to the flowing fluid is equal to that of the weight. The higher the flow rate, the higher the weight goes up the tube. So once the flow rate is higher, when the flow rate is higher, it will float higher, which go up the tube due to the high flow rate. The position of the weight is also dependent on the size and density, the viscosity and the density of the fluid, and the bore and the taper of the fluid. This is bore and taper of the tube. Okay. The rotameter has a low insertion loss and has a linear relationship to flow rate. In cases where weight is not visible, so this here is not visible, so you have an opaque tube. Okay, to reduce corrosion and the light, it can be made of magnetic material and tracked by a magnetic sensor. on the outside of the tube. So what if the pipe is an opaque in condition due to avoid corrosion, okay, you can use magnetic. So the magnetic sensor will track the outside of the tube to see where the weight is. Okay, the rotameter can be used to measure differential across a contraction flow in the both liquid and also gas. Turbine flow meter. An example of rotating flow rate device is the turbine flow meter, as shown in the left side of the slide. The turbine rotor is mounted. The turbine motor is mounted in the center of the pipe here, okay, and rotate at the speed proportional to the rate flow of the fluid or gas passing over the blades. So you can see here when the flow is starting to pass through the blade, the rotor will start circulating and the speed will be proportional to the rate of flow. The higher the rate of flow, the higher the speed proportional of the rotor start to rotating. Okay. The turbine blade are normally made of magnetic material or ferrite particle in plastic, so they are unaffected by the corrosive heat. So as the blade rotate, they can be sensed by a Hall device or magneto-resistivity element here, which is mounted on the outside of the tube. Sensor attached to the pipe. The turbine should be only used with a clean fluid, such as gasoline. Okay. The rotating flow device are accurate with good flow operating and temperature range, but are more expensive than most of the other devices. Moving vane. Okay. Moving vane, you can the cross sectional of a moving shape vane are shown in the figure below. This device can be used in a pipe configuration as shown or to be used to measure open channel flow. The vane can be spring loaded and able to pivot by measuring the angle till the flow rate can be determined. So once flow is flowing through this vane, it will tilt. So the angle of the tail can determine the flow rate. Okay, what is the flow rate of the liquid or gases or fluid? Another type of flow measurement is the electromagnetic flow meter. Electromagnetic flow meter can only be used in a conductive liquid. So you must remember the name itself showing that this type of flow measurement can only be used in a liquid that are conductive in nature. The device consists of two electrodes. It has two electrodes mounted in the liquid on opposite side of the pipe. A magnetic field is generated across the pipe perpendicular to the electrode as shown in the figure. So the figure here show that the magnetic field is generated across the pipe due to the two electrodes mounted in the opposite side of the pipe. Okay, so to the two electrodes mounted on the both opposite side of the pipe, this will eventually form a magnetic field generated across the pipe perpendicular to the electrode. Okay, the conducting fluid flowing through the magneto, the conducting fluid that flowing through the magnetic field generate a voltage between the electrode, which can be measured to give the rate of flow. So the conductive flow here, and then it will cause voltage between the electrode that are mounted on the opposite side of the pipe, and this electricity will give you the voltage, which give you the value of the rate of flow. Okay, the meter gives an accurate linear output voltage with flow rate. Okay, there is no insertion loss, and the reading are independent of the fluid characteristic. But it's relatively this type of flow measurement device is a quite expensive. Okay, pressure flow meter. Pressure flow meter. Okay, you can see here this example of pressure flow meter. Use a strain gauge to measure the force on object placed in the fluid or gas. So it's use a strain gauge which is mounted here to measure the force on object placed in the fluid or gas. Okay. The force on the object is proportional to the rate of flow. So the force that they acquire, okay, to the strain gauge is proportional to the rate of flow. So the higher the flow, the higher the force on the object. Okay, the meter the pressure flow meter is relatively quite low cost. However, it has a slight disadvantages. We said it only have a medium accuracy to measure the flow rate. Flow measurement instrument, the total flow. Okay, include devices used to measure the quantity of liquid or fluid flowing or the volume of the fluid in the flow. Okay, positive displacement meter use container of known size which are filled and emptied for a known number of time in a given time period to give the total flow volume. Two of the more common instruments for measuring total flow are the piston flow meter and the notating disk flow meter. For the piston flow meter, it consists of a piston in a cylinder. Initially, the fluid enters on one side of the piston, filling the cylinder, at which point the fluid is diverted to other side of the piston via valve, and the output port of the full cylinder is open. Okay, the redirection of the fluid reverses the direction of the piston and fill the cylinder on the other side of the piston. The number of times the piston transfers the cylinder is a given time frame giving the total flow. The meter has a high accuracy but is quite expensive. Notating this meter are in the form of a disc that oscillate, allowing a known volume of fluid to pass, which is oscillation. The oscillation can be counted to determine the total volume. This meter can be used to measure slurry, but it is also quite expensive, quite expensive, such as a piston meter. Velocity meter, normally used to measure the flow rate, can also be set up to measure the total flow by tracking the velocity, knowing the cross-sectional area of the meter to totalize the flow. By measuring the flow and knowing the density of the fluid, the mass of the flow actually can be measured. So you need to know the flow rate and the density of the flow. So then and eventually you can determine the mass of the flow. Mass flow instruments include constant speed impeller turbine with spring combination that relate the spring forces to mass flow and device that relate heat transfer to mass flow. Anemometer. Anemometer is a measurement that can be used to measure gas flow rate. One method to keep the potential of heating element in the gas flow constant and measure the flow required. The higher the flow rate, the higher the amount of the heat required. So when the flow rate is increasing, so as the amount of the heat also needed to increase. Okay. The alternative method, hot wire anemometer, is to measure the incident gas temperature and the temperature of the gas downstream from a heating element. The difference in two temperature can be related to a flow rate. Micro machine anemometer can now widely used in an automobile for the measurement of air intake mass. Okay, the advantages of this type of sensor, they are very small, have no moving part, pose little obstruction to flow, have a low thermal time constant, and are very cost effective along with its long irritativity. So this figure on the right hand side here show example of an anemometer. It has a revolving cup and also generator to measure the gas flow rate. Flow measurement instrument, open channel flow. Open channel flow occur when the fluid flowing. Open channel flow occur when the fluid flowing is not contained in a pipe but in an open channel. The flow rate can be measured using constriction as in a content flow. A weir used for open channel flow is shown in a figure A. This device is similar to in operation to an orifice plate. Okay, the flow rate is determined by measuring the differential pressure or liquid level on either side of the constriction. So how determine the flow rate? By measuring the differential pressure or liquid level on either side of the constriction. A partial flow is shown in the figure B here, which is similar shape to a venturi shape, which is shown in the previous slide. A paddle wheel, okay, or open flow channel are alternative method of measuring open channel flow rate. So actually, this is an alternative in measuring open channel flow rate. The selection, okay, the selection of a flow meter for a specific application to a larger extent will depend on the required accuracy. So what type of accuracy that you require? The presence of particulate, whether there are particulate in the fluid or whether or not. Although the required accuracy is sometimes downgraded because of the cost. So this need not, you must avoid it. Doesn't mean you want to save the cost, and then you jeopardize to select uh, flow measuring device which is not having a good accuracy. One of the most accurate method in magnetic flow meter, which is can be accurate to 1% of full scale reading or deflection or FFT. Okay, so it had magnetic flow meter. It has very high accuracy compared to the other flow meter. Okay, the meter is good for low rates. Okay, low flow rates with high viscosity and has low energy loss, but it is quite expensive and can only be used in a conductive fluid. The turbine gives high accuracy and can be used where there is no vapor present. So you must remember, once you want to do magnetic flow meter, there must be no vapor present in the pipe. But the turbine is better with clean low viscosity fluid. The next slide will show you a table that will give you a comparison between each flow meter characteristic. The general purpose and most commonly used devices are the pressure differential sensor used with pipe constriction. Okay, table here show you the summary of the flow meter characteristic. You can see here there is a flow type of flow meter. There is orifice plate, venturi plate, flow nozzle, dull tube, elbow, pilot static, rotameter, turbine meter, moving vane, electromagnetic, vortex meter, strain gauge, notating this, and also anemometer. This all already been covered in the previous slide. And you can see here the range of each flow meter, and then this column here show the accuracy percentage of the each flow meter, and this here show you the general comment, the advantages and advantages of every flow meter. For example, for the orifice plate, it is low cost, however accuracy is also low. For the anemometer, it has low losses, but however, it also has a fast response. Okay, these devices that are flow meter that are shown flow meter here they are shown give you accuracy in 3% range when used in a solid state pressure sensor, which converts the reading directly into electrical unit or the ratometer for direct visual reading. The venturi tube has the highest accuracy and least energy loss, followed by the flow nozzle and the orifice plate. You can see here the venturi tube has the highest accuracy, okay, followed by the orifice plate. Okay. For cost effectiveness, the devices are in a reverse order. Okay, In large amount of particulate are present, the venturi tube is preferred. So if there is a particulate in the flow, the venturi tube is preferred. Okay, the differential pressure device operate between 30 and 100% of the flow range. The elbow should also be considered in this application. The elbow that I show you in previous slide. Okay, gas flow can be measured with anemometer. Anemometer here that has a cup here to measure the gas that is being shown in previous slide. Solid state anemometer are now available with good accuracy, are very small in size, and are cost effective. For open channel application, the flume is more accurate and best is if particulate are present, but it's most expensive. The particular extension should be also be given to manufacturer specification and also their application notes. Okay, so for today, this is the end for today mini lecture. I will continue for the next mini lecture regarding this topic. I will continue with slide number 28 for the next mini series. So thank you for your time. I hope you will go through the video and also go through the notes which already being shared with you previously. I also you also will stay strong and stay safe at home. Okay, assalamualaikum and have a happy have an enjoyable day at your home. Please stay safe and also take care of yourself, also your family, and then take this time to as an opportunity for you to be with your family as a blessing in disguise. Okay, hope you have a good day ahead of you and assalamualaikum and salam sejahtera.